Hey guys, good morning all. Just give me a chat if you guys can hear me and see the sublime text. Quickly give me the chat if all of you guys can hear me and you guys can see the sublime text. If you can, cool. Let's quickly start with today's session. What we have covered till so far, I'll quickly revise it, then we'll start with today's session. So yesterday was our last class. We were talking about the questions based upon hashing, right? Today we'll be finishing up hashing and we'll be starting with our new topic, which is dynamic programming. Okay. Now, first thing first, understanding the minor theory of hashing, understanding hash set versus linked hash set versus tree set, and why Java provides me three different kind of set. Same reason Java provides me three different kind of map also: hash map, linked hash map, tree map. The difference is that in a hash set, my order is not guaranteed. It can store in any order. It can store in the same order. It can store in the opposite order. It can store in any random order. In linked hash set, my order is guaranteed. Order means the same order as in the original array or list. Tree set means I'm going to store in the ascending order. This is provided in Java because of these three reasons. In C++, there are two different categories: unordered set, unordered map, and ordered map. Unordered means without any order, as the name says. Ordered means they are in sorted order. In Python, the dictionary is sorted, the set is sorted. Okay, this is the code example we talked about. The difference between a set and a map is, in case of a map, if you try to update the value will be overwritten. In the case of set, the value will not be overwritten. Okay, we write down a small code to understand how the hash map and hash set looks like in Java, and writing the code and understanding the part we just talked about, overwritten part. Then we talked about time and space complexity. So in terms of a map, we say that insert and lookup is big of one time. Insert is anyways big of one time. Same we say for set, insert and lookup is big of one time. But the lookup is not always big of one time. In worst case, it can go to big of log of n because they're built on top of binary search trees. Okay. Space complexity is going to be big of n, that n is going to be the number of unique elements, not the size that you're putting, it's just number of the unique elements that you're putting there. Then you move on to the question. We start with question number 1, which has been asked in PayPal, lead code 205 isomorphic strings. A good important question to start with, at least from hashing. The word says isomorphic means they are going to talk about same form. So it's a question which is a combination of two games, Scrabble, and finding the difference between two pigs. What this question is talking about is you're given two strings, string 1 and string 2. If string 1 can be converted to string 2 by following some form of mapping and rules or validation, that is when it will be called as isomorphic. There's certain validation rule given here. Number 1 is all occurrences must be replaced by same character. No two characters may map to the same character. One character may map to itself. Okay. So if you look at this, this is an isomorph. This is not an isomorph. We talked about various other cases to clarify that. We move to the code part. So the solution includes two strings are considered to be isomorphic if positions of character follow the same pattern. Or you can say if the index pattern matches. Now, what do you mean by index pattern? Index pattern in the sense I'm going to create a map where I'm going to store my key as a character, my value as an index. And if same characters are replaced in all occurrences, I can say it is isomorphic in nature. So we check the base condition first. If both strings are empty or both are same, definitely they're isomorphic. If one is null and other is not null, then it is not isomorphic. If length differs, definitely they cannot be isomorphic. Now I create two maps, map 1 and map 2, first ordering first and second string respectively. I'm storing what in the map? I'm storing the element and its corresponding index. Now I'm comparing. If index s is not equal to index 2, I return false. If I complete the entire iteration of both the strings, then I return true. Time comes to big of n because I'm going to iterate over both the strings. Space complexity is going to be big of 256 plus 256 in the worst case. So n can be 10 to the power 4, but at max I can have 256 unique characters, and they're built upon ASCII characters. Then we move to question number 2, which has been asked in Tower Research Capital. Quite a good question, lead code 128. The problem statement says, given an unsorted array of integer num, return the length of the longest consecutive element sequence. Now, when you say longest consecutive element sequence, you need to understand, it's not talking about subsequence or subarray. It's talking about numerically the longest sequence, right? Numerically in the sense, this 4, 1, 3, 2, if I write as 1, 2, 3, 4, 4, 1, 2, 3, 4 is neither a subsequence, it's not a subarray, it's a subset out of this, right? So whatever is the numerically longest consecutive sequence you can find, that is what you need to give the answer to. And second thing, if duplicate exists, it will not make any impact, right? So 1, 2, 2, 3, 4 or 1, 2, 3, 4, in both cases, my output will be 4. Then you move on to the solution part. Number 1 is a brute force approach using sorting. What I'm going to do sorting is, what's the reason and intuition behind sorting? If I sort the values, it will be in the increasing order, so it will be easier for me to check for the longest consecutive sequence. Same values will be together, so it will be easy to check for the same adjacent element as well. So I can put my integer count equal to 0. I can compare if nums of I equal to nums of I plus 1. In that case, I'm going to increment the count. If it is same, I can just continue. If it is not same and it's not increment either, in that case, I'll reset the counter to 0. I'll keep a track of maximum. Why do I need to keep a track of maximum? Because it can be more than one consecutive sequence. So here we write down the code in terms of sorting based solution. These are the three conditions we just talked about. we return the math.max count, comma, current length. Time const n log n space comma big of 1. Now, this is fine. This is a brute force solution for it, but can it be optimized further? The answer is yes, and that's the expected solution in the interview. It can be found in a single iteration if you iterate over it. That's optimized solution using set. So what do? You traverse the array and you check in set if element -1 exists or not. If it exists, you plus plus count, otherwise you don't. So I can keep maximum of that count, that will remain the same. The purpose of using a set is the lookup time is big of 1 as compared to array. Okay. So this is my array. If I make a set out of it, what I'm going to do is my current length is 1. I'll take, let's say, for 4, I will check 4 minus 1 exists, 4 minus 3 exists, 3 minus 1 exists, 2 minus 1 exists, so on and so forth. Time comes to big of n, space comes to big of n. So we write down the code in Python, then we write down the alternative code in Java, then we write down the code in C++ as well. Okay. O n time, O n space, most optimized solution. Then we move to question number 3, which is lead code 389. Find the difference. Another good question. So this problem statement is, it has multiple ways to solve it. We discussed about the problem statement, but we did not write the solution for it. So I'll take this problem statement here for today. And that's where we are going to start with. But more or less, the problem statement is you're given two strings. I'll just make it separate here. You're given two strings s and t. What you need to do is string t is generated by creating extra character to string s. So t contains basically one more character than s. You need to find out what that character is. That is why the word find the difference, you're returning one character. All right, guys, that being clear, let's start with today's session. Anybody has any doubts, please let me know. If you guys are clear, type please in the chat. Come on, guys, be quick. Everybody crystal clear? Cool. Let's talk about the solution directly. We have spent already time for it, so I don't want to give further time for this question. This question has many different solutions. Let's go step by step in all these. Let's start with the brute force solution. If I have to compare between two strings, I need to know in the second string what is the extra character. The brute force ways I can run two nested loops. So if you run two nested loops, what is going to happen? S of I is not equal to T of J. Is that what you're going to check, or it's not containing T of J, so on and so forth. Time complexity, big of n square. Space complexity, big of 1. This is the most brute force solution. Second, I can use sorting and two pointers. Why sortings? Because value can be at any index, right? So if you sort them together, at least they will be at, and then you can compare by using two pointers. So I can do s dot sort, and then you can do t dot sort. So A, B, C, D, let's say after sorting, A, B, C, D, E after sorting. So you can have your first pointer, let's call it as P1 pointing here. You can have your second pointer, let's say P2 pointing here. Okay. So what you can do now? Now you can compare. So iteration would be one time only. So time constant would be big of, let's say, m log m plus big of n log n plus big of m plus big of n, which is just m log n plus n log n. And space comp is going to be big of 1. And n is what exactly? N is m plus 1, because it's just one extra character. Everybody crystal clear with these two solutions? Come on, guys, quick in the chat. Pretty straightforward, right? Third, so we start with n square, we reduce to big of n log n. Can we further reduce it? The answer is yes, we can further reduce it. We can keep a map. If I keep a map, I can count for each character, and then I can compare the maps. So one way is that I can keep two different maps, and then I can compare the non-common key or non-common value. Basically compare between two maps. That's it. Okay. So let's take an example. If I got this guy ABCD and ABCDE, I come here, I can compare this. So I can create my map1, MP1. So A1, B1, C1, D1. That's going to be the frequency. And if I talk about my MP2, then what's going to happen? Copy this, paste it, add one more thing, which is given. Now you can compare between the two maps. Time constant would be big of n plus big of n. Space constant is going to be big of Let's see if it is a sky character, so what? Lowercase English characters. So in that case, it's going to be big of 26 plus big of 26. All agree with this? Quick in the chat, guys. Third solution using two maps. Okay. I'm coming to that. We are trying to reduce from most brute force to the more optimized solution. Okay. That's solution number 3. Solution number 4. Map based only, but is it mandatory to use two different maps? Can we solve it in more optimal way? Yes, we can solve it in more optimal way. So we can keep one map where we can count for each character and check if frequency becomes 0 or not. Why frequency becomes 0? Because we are going to use one map. In that one map, what we are going to do? You traverse the first string, you increment the frequency. You traverse the second string, you decrement the frequency. If whatever is the uncommon value, whatever is the additional value, that will be the only value which will have the frequency non-zero. Agree? All the common values, if you're incrementing the frequency in first string, decrementing the frequency in second string, they will become 0. Any value which does not have the frequency 0, that is the element which is your extra character. Okay. So you can take an example for, again, this guy. I'll put it here. This time we're going to have only one map. So there's no point of MP1 and 2. Here A will become 0, B will become 0, C will become 0, D will become 0, and E will become -1. Let's put it as -1. Okay. So if frequency is not equal to 0, basically if value is not equal to 0, I'm going to return that key here. Time constant, big of n, and big of n plus big of n if you want to call it, space empty big of 26. Everybody crystal clear with this fourth solution? I'm coming to that, guys. I'm coming to that. Why space company big of 26? Because the question said we can contain only lowercase English letters. Okay. If it was a sky character, that will be 256. But the question says only lowercase English letter, that's why 26. Okay. All right. That being said, these are four solutions that we discussed. Let's see what more solutions can exist. Same thing that you have done in the map, you can do it with frequency array also. So copy these two solutions. You can do it by frequency array. So I'll just call it as frequency array, right? Two different frequency array and compare arrays. Okay. You can just do the same thing. Everything will remain exactly same. Nothing would change. Time and space quantity would be the same. So and so forth. Even this also you can write big of n. You will be iterating both the strings. Okay. Number 6, exactly same. Again, exactly same. This is exactly same. Okay. Instead of map, we are going to replace with frequency array. That's it. There are 6 solutions we talked about. What else? Anything else that we can think of? Yes, we can think of. We can think of XOR here. Now, even in XOR also, we can have 2 pass and we can have 1 pass. What is the XOR solution and why the XOR solution here? We know the property of XOR. Also, because it's difficult as compared to map. It's the same time and space complexity. It's not difficult. It's just creating an array that's simple, right? I mean, depending upon use case, if you're dealing with very large values, I would recommend using a map. But if you're dealing with very small values, for example, in the case of only SKY characters here, which is 256, only English 26, it's good to go with frequency array as well. In some of the cases, frequency array has a better optimization than map because array is built upon arrays and map are built upon BSTs. Okay, that's why it's good to talk about. But anyways, that makes difference once you're dealing with extremely competitive programming contest. In your normal day-to-day life, you won't even notice the difference. Anyways, coming to the XOR one-pass solution, what's the idea behind XOR is? We know about the property of XOR is that if you take a XOR of an element with itself, the output is 0, right? So if I take XOR of all the values, I have two strings, I have duplicates in both the strings. If I take XOR of all the values, whichever is present in duplicate, that will cancel out them. So XOR will become 0. And we also know the property that XOR of a number or character with itself is actually that number itself or that character itself. So whichever will be the pending one, that will be the final answer. So only pending output would be the extra character. So I will say string S, XOR of string T. That will give me my final answer. Take an example. A XOR, B XOR, C XOR, T. And if I take XOR with A XOR, B XOR, C XOR, D XOR, E. Now what is going to happen? A XOR A, B XOR B, C XOR C, D XOR Z, they will cancel out each other. Eventually you will have E as your answer. This is what we are talking about. Okay. Time complexity, again, traverse both the strings, big of n plus big of n. Space complete big of 1. So now we are at our 8th solution. We started with big of n square and we moved to big of n log n. Then we moved to extra space. And finally, we are in single iteration of both the strings with extra with space complexity is big of 1. Everybody crystal clear with this. We start with n square, then we reduce complexity to n log n, then to n. And we increase the space, we move to big of 26 plus 26, then we move to big of 126. And finally, we have moved to a constant space. So simple two iterations of a string and constant space. This is the most optimized solution. I mean, till this part, even if you give this answer in the interview, it's completely fine. You are well accepted. There is two more solution though, or technically one more solution with an optimization on top of it. No, it's not necessary that XOR works for integers only. See, the way any binary operator works is it converts into an equivalent binary part. So when it converts into equivalent binary part, it can be a character which will be converted, or eventually it will be converted for a string as well. Okay. Even when you say tens or 10, it's not working on 10 itself. It's working on the binary equivalent of 10. Okay. Can we retry using hash set, initially adding element of string and removing from hash set? Initially adding element of one string, next time removing from hash set. So for the hash set, the problem is that the value can be duplicate, right? So that's the first thing that we discuss, why set is not a good solution here. Since duplicates exist, hash set is not a good solution here, not a right choice here. Okay, that's the only reason. Cool. Coming back to this, these 8 solutions are fine. Let's talk about few more solutions which can exist for this problem statement. Number 9 is, before I tell you the approach, let's take one thing to understand. Everybody crystal clear with these 8 solutions, right? Anything which is not clear, let me know. I told you this question has multiple solutions. Okay, cool. Let's try to make this the solution number 9 and solution number 10. Let's try to make this an integer problem. Then we can convert into corresponding character or string. If your task was something like this, given 2 numbers, find the uncommon digit or find the different digit, whatever you want to call it. So if I say P is equal to 1, 2, 3, Q is equal to 1, 2, 3, 4, your output will be 4. This is what the question is. Exactly the same question. You got one extra character. Here you got one extra digit here. A good approach could be, I can take sum of digits and then I can subtract. That will give me my answer. Means sum of Q, which has the extra digit, will be 1 plus 2 plus 3 plus 4, which is 10. Sum of P, which is 1 plus 2 plus 3, that is 6. Then difference would be the uncommon digit. That is going to be 10 minus 6. That is going to be 4, which is my final answer. Everyone agrees with this. Everyone agree with this. Okay. This was for number. Can we extend it to string? The answer is yes, we can extend it to string. I can say P equal to ABC. I can say Q equal to ABCD. And then what I can do? If I have to take the difference, I need some form of mapping of this character A with some number. How I can map a character to a number? By default, programming provides me. What is that? What is that programming provides me? My programming provides me ASCII character. Every character is mapped to its ASCII character value. I just need to use that because eventually I need the difference. So what I can do? I can say sum plus equal to T of I and then sum minus equal to S of I. So what this line is going to do? Sum is going to be A plus B plus C plus D, which is what? 97, 98, 99, 100. And this is going to be sum equal to D, because if you subtract A, B, and C, you will be left with this. And then what do? You will typecast it back. So you will typecast it back from that integer value. So that will give your output as T. Everybody crystal clear with this approach? Come on, guys, put in the chat. Okay. Now, even if you give this solution, this is completely fine. The output is going to be what? You anyways have to traverse both the strings, so you cannot reduce it less than big of n plus big of n because you have to. There is no other way. So my time and space quantity would be exactly same. I have to traverse both the string. My space quantity would be big of 1. And this approach is called what? This approach is called sum of ASCII characters. Okay. However, there's always a difference between a good engineer and a very good engineer, right? What is something that we can still optimize on it, or what is something which can be edge cases here and then we can optimize on it? Okay. Let me give you 10 seconds to figure that out between this solution, then I'll tell it. What can be the possible caveat that you can think that in certain possibilities, this might not be a good solution, or in certain possibility, this solution might not work? 10 seconds, guys, be quick if we can figure out. Tell me about the scenarios where this solution might not work. Correct. See, this is a very good solution. The only caveat is what we are keeping it as a sum. If you're keeping as an integer, there might be chance it can overflow. If you're keeping it a long, still there might be chance it can overflow. In order to know that, we need to come back to the constraints. I come back to my constraints. Let's talk about it. This is what my constraints are. So my constraint tells me one thing. My A to Z is 97 to 122. My capital A to capital Z is 65 to 90. In this question, I'm only talked about in the sense of only lowercase English letters. Okay, the words might change, it might be ASCII characters, so on and so forth. So if I talk about maximum value with this constraint, it can be z up to 1000 characters. All agree with this? That is the maximum that we can reach for. Small z as the highest value, which is 122. What can be the worst case scenario? The worst case scenario will the string would be of full length, which is 1000 length, and every character would be at the maximized value. All agree? Come on, guys, speak in the chat. Okay. So in that case, the maximum sum value can be 122,000, and that is well within the range of integer values. So we don't need to worry about for this test case or for this problem statement for sure, right? But if I take the same thing, and that's one optimization we are going to do now, and it's a mathematical trick which can be used in a lot of places, but I took here so that you, in case when you solve any CP problem, you might utilize this problem statement or this trick as well. If this becomes 10 raised to the power 9, just imagine it becomes 10 raised to the power 9, exactly same question. Now, if it becomes 10 raised to the power 9, then this will become 9 to 1.22 into 10 raised to the power 11. Then it is not going to be within range of integers. All agree? If my length of string becomes extremely high, then it is not going to be within the range of integer. All agree with that? Come on, guys, quick in the chat. Okay. We'll talk about the solution. Let's talk about the problem statement first. The problem statement is this is a well-defined solution. This will easily work for this problem statement, will work the solution, no issues. But if the string length becomes extremely high, in that case, this solution may or may not work. I mean, definitely, if you're keeping an integer, it will not work. Okay. Problem statement clear to all. Okay. Now, if the problem statement is clear, now you guys tell me the solution. One solution, two solutions that I got in the chat was big integer we can use. We can iterate the string alternatively. Anybody else? Come on, guys, quick in the chat. What can be the solution? Minus approach. That is one way. What else? Some prefix not sure. Cool. Because there are multiple workarounds for it, right? One workaround could be if you don't want to keep it integer, convert into long or big integer in Java, etc., etc. Or if it's very long, you can convert it to string as well. Not a good solution, but I'm just talking about what can be the possible solutions here. Second, you can use the minus approach, alternative turning both the strings, use the minus approach. Third can be modulo-based approach. Okay. What is the modulo approach? I can use a modulo trick here. And what I can do as part of modulo trick is wherever is my sum, I can keep sum modulus equal to 256. You can keep 256, you can keep 26, whatever that is. Okay. Because for any value, my sum always is from 0 to 255. If you take modulus k, the sum will always remain between 0 to k minus 1. So with every part, you can take the modulus 0 to 255, and that will keep your answer between 0 to 255 for every character that you have added. Okay. And then you can traverse over the second string to first take a sum and then go over the first string to reduce the sum. And that will give your answer. So let's verify that via code real quick. Come back here. Let's look at the code part, whatever we discussed so far. Move to C++. All right. These are the solutions we talked about in detail. Now coming to this part. What I'm going to do here. What I'm going to do here is I'm going to simply keep a trick which is going to take value of till 256. So I traverse over the second string. I will do sum plus equal to C. The moment I add any character, I take modulus 256. Okay. Then when I go over the first string, I subtract it. Again, I take the modulus 256. And then I'm typecasting back to get the actual character. Time const big of s plus big of t. Both the strings need to be traversed. Space comma big of 1, not using any extra space. Everybody crystal clear with this approach? Quick in the chat, guys. Everybody crystal clear with this approach. Okay. If all good, let's compile the same. Let's submit. It's 100% of the solution which we expect. Time comes to big of s plus big of t. Yep, it should be space comma to big of 1, which it is. Okay. So there's nothing much to write in here. All we are doing is simple taking a modulus of 256 value. But if you still want to, let's do real quick. Here, here, and here. So let's do here. I will take a very simple example. Let's take ABC and let's take ABCD. Okay. Let's quickly go for diagram. Cool. We got the value which is converting C, which is the value of A, and then we got the value 256. S is ABC, T is ABCD. So if I go with the first value, sum will become 97. Why? Because the sky character of small a is 97. Continue. B, 97 plus 98 becomes 195. Continue. Now the modulus part will kick in. The moment it calls the value of 97 plus 98, it will take the modulus with 38. Continue. You got the value. Now you start subtracting. Becomes 138, becomes 41, minus 57, and finally minus 50, 156. So if you take the minus 156 out of typecasting it, it will give you the answer, which is character D here. Okay. All right, guys. That being said, let's quickly take this code part and move to the solution here. I remind you here again, there are multiple most optimized solution here. Repeating. Yeah, I'm coming to that. There are multiple most optimized solution here. What solution you should give an interview? I mean, the 10 solutions we discussed about, I would say suggest the map solution, map slash frequency array. You don't need to write two different parts. I've wrote it because for your understanding. Even if you give a XOR-based solution or sum of STI character, both are acceptable. I would prefer to give a XOR-based solution for experienced candidate. Okay. All right, guys. That being said, this is something we discussed. Now move on to the next question. This was question number 3. Cool. Let's move on to question number 4. Question number 4 is really good. Let's quickly move on and let's talk about this question. This is tagged as a lead code hard, but let's try to solve this. Lead code 819. This is most common word. Okay. If this question is asked, most likely this is going to be the only question to be asked, because if in a 45 minutes this question is asked, there will be very less time for a follow-up question or second question. Okay. So most likely this will be the only question asked. And these are some of the questions which can be asked. For example, usually the pattern is 2 coding question in 45 minutes, but sometimes the question is big enough, so you have only one question because the question has subparts. So let me open this problem statement first, then we'll talk about it. Oh, they tagged it as easy. Anyways, it's not easy for sure. Let's come back here. Cool. This is lead code 819. Let me share my screen real quick. If you look at the stats, it has almost 1 million submission, 92.9.5K. Acceptance rate is 44.6. Look at the company which I've asked this question. Some good product-based companies. You can see the names here. What does the problem statement says? The problem statement says you're given a string paragraph and a string array of the banned words. Return the most frequent word that is not banned. It is guaranteed there is at least one word that is not banned and that the answer is unique. The words in paragraph are case insensitive and the answer should be returned in lowercase. Note that the words cannot contain punctuation symbols. Okay. They've given some examples to understand that, and then they have given constant. My paragraph length is up to 1000 and it's not empty. Paragraph consists of English letters, spaces, or one of the special symbols here. My band length can be empty, can go up to 100. My band I dot length can be from 1 to 10. Band I consists of only lowercase English letters. Okay. So the reason I said if this question is asked, this will be the only question to be asked because there are multiple sub problems of it. So let's try to understand the problem first, then we'll try to talk about solution. This is the problem statement. Let's start with this. Example 1. This is input, this is output, this is explanation. Then this is example 2, input, output, so on and so forth. Okay. So first we're going to talk about understanding. And even before understanding, let's talk about what our function is expected to return. So my function is expected to return a string. Okay. It's going to be the most common word. I'm given 2 input, one is string paragraph, one is string array of banned words. Okay. Let's understand the problem statement first. It says ignore the punctuations. Okay. We'll do that. Means if the word is balls, comma, I'm going to read it as just balls. Okay. Number 2, it asked me to ignore any extra characters. and spaces. So my string can contain this extra character and this space. Number three, I need to ignore uppercase and lowercase. What do you mean by uppercase and lowercase? My questions very specifically said that it's case insensitive. Okay. There would be some statement. Yeah, this part. It says it's case insensitive. Okay. So I need to ignore uppercase and lowercase. Then I need to check word is not banned. I'm given a string array band to check that. Number five, find most frequent word based upon the count and then return the word. My question said it is guaranteed. Where it was written? Yeah, this part. My question said it is guaranteed that the answer will exist and it's unique. Okay. Now let's try to understand this. The problem has given me 4 or 5 conditions, and these 4 or 5 conditions make this question lengthy. First, you have to ignore the punctuation. Remove this. First, you have to ignore the punctuation. Second, you have to ignore the extra character and spaces. Third, you have to ignore the case insensitiveness. Fourth, check if the word is not banned from the string array which is given. And after doing all of that, you need to find me the most frequent word based upon the frequency. It is guaranteed the answer would exist and it's always going to be unique. The test case are generated like that. Now let's take a simple example to understand it. My paragraph says, Bob hit a ball, comma, the hit ball flew far after it was hit. My list of string array which is given as ban is hit. Okay, so let's take first thing first. Hit is counted as 1, hit is counted as 2, hit is counted as 3, right? If the band does not contain hit, my output would be hit only. Agree? Hit has the highest frequency, which is 3. But my band word contains hit, that's why hit cannot be the answer. Okay. So what is the second highest? Second highest is ball. Now, if you look at this ball, it has a frequency 1, and this capital ball is the same as the small ball. So the frequency becomes 2. And ball is not part of the band word. That's why my output becomes ball. Everybody crystal clear with this? Come on, guys, quick in the chat. There are multiple rules we are applying here. I'll go back here. I'll talk about. First rule, we ignore the punctuation mark. This ball contain a comma with it. This ball does not contain a comma with it. Still, we count the frequency to be 2 here. Number two, we are ignoring the extra characters and spaces. For example, this extra character, all of the spaces we are talking about, we are ignoring that. Number three, we are ignoring the uppercase and lowercase, this small ball and this capital ball. We count both of them as 2. Number four, we're going to check if the word is not banned. We are given a banned array for this. And number five, we are checking the most frequent word based upon the count, of course. So that we are checking, hit has a count of 3, ball has a count of 2. Hit is a banned word, so it cannot be the answer. Ball is not a banned word, that's why it is the answer. Everybody crystal clear with the problem statement now. Everybody crystal clear with the problem statement. Cool. If everybody's crystal clear, you guys know the drill. I'll give you the lead code link. Let me find it real quick. This is your lead code link. Putting that in the chat here. And this is the function that you have to complete. Directly go ahead on the lead code, start submitting the solution in whatever language you are most comfortable with. Please change the message directly to me. Do not message to everyone. And once you guys are done, then let's go for discussion. Okay. Your time starts now. All right, guys, enough time. Let's start discussing the solution now. Okay. Cool. Let's talk multiple things that need to be solved in this part of this problem statement. First thing first, what I'm given currently as a paragraph is one single string. So if you look at this, everything is given as one single string. The first thing we should do is we should convert this into array of string so we can take out the specific words, convert it into small case characters. Okay. And in that case, while we're doing it, we can split by space, we can split by extra characters, so on and so forth. So first thing, convert paragraph into array of strings. And how would we do that? This paragraph, let's call it as an array of string and call it as words, because that's the eventually words I would need to walk through. I can remove extra characters here. By extra characters, I mean this. Extra characters and spaces actually. Let's write both of them. Okay, I can remove that. Once I remove that, how do I remove that? First of all, I can use a regex for it if you want to implement, or if you don't want to use regex, you can use a split function also. However you want to do it. Your Java Lambda stream classes also provide some of the functions if you want to utilize that. Okay. First thing first, convert into so that we have a list of string words that we actually need to compare. Next, convert all string in my string array of words to lowercase. Okay. Why do I need to convert into lowercase? Because if you look at the second band array, my band array is always lowercase. Okay. This is given in the constraint. If I need to compare this word, whether it exists in a band array or not, two possibilities are there. If I convert everything in the band array to be uppercase and then I convert it to uppercase and then I compare, instead of doing two uppercases, I can simply do one lowercase and then I can compare with this because this is already lowercase. All agree? Come on guys, click in the chat. Instead of doing two uppercases, I can simply do one lowercase and then I can compare with the existing lowercase. Or you can simply compare with equals ignore case. That is also fine. However you want to implement it. Okay. So I have to match the words present in words array which are not present in band array. Okay. Number three. Now I got two string array of words and string array of band. I need to compare between these two arrays and I need to check those words which are not present in this array. So basically I've given two arrays. I need to compare between two arrays what is not present in the second array. Now, question becomes find most common word which is present in this words array, but which is not present in band array. All agree? Let's begin the chat. Now my question becomes, I need to find most common word which is present in words array, but which is not present in the band array, right? Now, what is the best data structure for it? The best data structure for that is set. Why? Because lookup time for array is going to be big of n, but lookup time for set is going to be big of n. Okay. So if I check a word, let's say which is present in words, and if I compare whether it is present in band or not, if I'm taking it as an array value, it will take big of n. So for every word in words, I need to compare big of n there. So it will become m into n code. But if I convert this value into set, so convert band array into set, and then I do lookup over band array in big of one. Okay. So in that case, I would need to do for every word, my lookup would be big of one. So it will be big of m into big of one. Everybody crystal clear with this? Someone guys speak in the chat. Someone guys be quick. Everybody crystal clear? Okay. There was one question which I missed. Let me see. Is it acceptable in interviews that I don't know exact write but I write everything else? You can leave a placeholder in the code. You can say like I am not exactly familiar with the format. Most likely interviewers will skip that part. If you do everything else correctly, I don't think that's going to be much of an issue. Okay. This is convert band array and then look up in big of one. What else? Once you have done till this part, now the last part of the question is most common word. How do you find the most common word? So most common word will be by frequency. Which data structure you're going to use for frequency? You're going to use a mapping. Okay. So in my map, the key is going to be a word and the value is going to be a frequency. Okay, that's all we need to take care now. So quickly going through the four parts. Number one is I need to convert paragraph into array of string. So a paragraph will be converted into a string array. I can do it by regex, I can do it by split or any other method if you want to do it, lambda streams and all. Number two, I can convert all string and string array words to lowercase. So I can compare lowercase with lowercase because my band array is already given in lowercase. Third, now my question converts into I'm given two array of strings. I need to find that value or basically that word which is present in first array but not present in second array with the highest frequency. So for the highest frequency part, I can keep the map, I can keep the key and value frequency. But instead of comparing between two strings, I can convert the second string into a set. Now my lookup time would become big of 1 in the second string. If that is clear to all, let's quickly move to the code part. Let's look at the code of it. So we are back on lead code. Let's quickly look at the code. Is punctuation handling covered in regex? Yes. Cool. First thing first, what do we need to do? We need to complete this function which says most common word. I'm given a string paragraph. I'm given a string array of bands. So first thing first, I'm going to create a set out of the band array. So I create a band set, which is going to be a set of string. I create from arrays.aslist band, so which converted me a set. Second, I need to hash map for frequency of most common word. So that's going to compare integer and string and integer. Third, what do I need to do is I need to convert the string array of words either by using regex or however you want to do it, and when to convert into lowercase. So what I'm doing is I'm simply using replace all here. Wherever I find any extra character or wherever I find any spaces, I'm converted to lowercase. I'm splitting by these values. Okay. Now I got my string array of words and I got my band set. All I need to do is go over the string array of words, convert if the band set contains or not contain. If it does not contain, then I'm going to put that in my hash map with the value and frequency. And finally, what do? I iterate over my hash map. I get the key value, which has the highest frequency, and I return my answer here. Have a look at this code. Anybody has any doubts, any question, please let me know. Come on, guys, be quick. Only length program means length question. What do you mean by length question? Lengthy question, you mean? Okay, yeah. That's why I said it's going to be one question if it asks in 45 minutes. Anyways, guys, everybody crystal clear? All right, I'll take this as a yes. I'll compile this real quick. Looks good. Let's go for submission. If you use band array directly instead of converting to set, complexity would increase, that's all. So if you see here, this is the difference it will make. Now I'm comparing over the set, so big of n into big of 1. If you do not convert it into a set, it will take big of n into big of whatever the size of band set, which is sort of n square code. Okay. So if you look at the time complexity now, big of n, one iteration, which is fine. Space complexity is big of n here because we use set, we use map, which is fine. Space is what we are sacrificing here anyways. Let's take this piece of code, move it here, move it here. Ready. Okay. Alrighty. Does regex and split function contribute? Yes, they do. So if you look at this, I've written complexity at every part. So this is we are creating a set, space complexity is big of n anyways. This is the part we are splitting is that is big of n because once you split by using string, anyways we are iterating over the string as well. So that is big of n. This is big of n into big of 1, so totally becomes big of n plus big of n. That is again big of n. Even in this also, when you're iterating over the map, that's going to iterate over the entire map, which is not big of n, but at least big of unique length, which will be less than big of n. So in any case, your complexity remains big of n, and your space complexity becomes big of n as well. Okay. All right. Let's see. If we use band array directly instead of converting to set, can we expect interviewer share regex, or we have to remember? I don't think interviewer will share regex, but you can recommend approach. Maybe you can keep a placeholder here that if you don't know the syntax, you can just keep like, I'm going to use a split function, which is going to split based upon characters and the parts. And it's completely fine if you don't know the exact format, you can just put a placeholder there. Okay. Most likely interview, you will not be running the code. I mean, depends on organization to organization. Most in the fund companies, you will not be running the code altogether. Okay. But do mention over a comment that this needs to be a regex pattern, which you don't know. Either they can share the regex pattern or they can just quickly move on. It's like, okay, move to next. All right. Time complexity already answered. Is it good approach to add band values into regex to get it in the final para before creating map? Is it good approach to add band values into regex to get rid in the final paragraph before mapping? Band anyways is not containing any extra character, right? Words is the one which is containing extra character. And for word, we remove that value first and then we put in the map. Okay. Band array only contains the word. There is no extra character in band. Okay. All right, guys. It's given in the constant, by the way. If we look at this, this consists of only lowercase. So band does not have any extra characters. Alrighty, guys. If this is good, let's move on to our next topic, which is going to be an interesting one, which we call as dynamic programming. But we'll take one by one for that. It's a good topic, so let's make it dynamic programming. Okay, it's called deep in short. Before I start with this topic, this is one of the topic which I feel as a mentor that a lot of mentees are worried about or afraid about. So this is what I do usually. We are going to take around 3 sessions, 2.5 or 3 sessions of dynamic programming. This is what I do with every batch, and this is what I'll do with your batch as well. I start with an initial assessment just to understand how much comfortable you feel before the session of dynamic programming. And once at the end we are done with dynamic programming and we move to the next topic, I will revisit that. So expect like where have we reached there? Okay. So being honest with yourself, on a scale of 1 to 10, whenever you get a DP question, 1 being the minimum, 10 being the most, how much would you rate yourself? 1 being that you are not confident at all, 10 being you are very confident while solving a DP question. Quickly in the chat, guys, you can message to everyone, which is completely fine here. You can message to everyone, guys. Okay, 4, 5, 6, 7, 1, 1, 1, 1. Okay, most of you, no idea what DP is. Then you can start with 1 at least. 3, okay, 3, 7, 4. Cool. The highest I've got is 7 so far. Nobody with 9 or 10. 5, 6. Okay. Anybody else who's yet to answer? Quick in the chat. 3. Cool. So on an average, I got the answer of 1 and 2. There are outliers like 7, 6, 5, or 3, but on an average, I got the answer 1 and 2. Next question. Same question for recursion on a scale of 1 to 10. How confident you feel solving recursion question? 1 being minimum, 10 being maximum. Quickly answer the chat, guys, for recursion. Now see the numbers are spiking up. 9, 5, 3, 8. Okay. 8, 3, 9, so on and so forth. Cool. 2. Anybody else? Recursion? Okay. For recursion, I've seen the average is 5 to 6, which is good. You guys feel more confident in solving recursion question as compared to the DP question. Now let's put a target here. And that's what I do with every batch. Once we are done with these 3 sessions or 2.5 sessions or whatever number of sessions we have DP, my target is I'll revisit the same question. And my target is we will take this average, which is currently 1 to 2 to 8 to 9. I'm not promising 10 because it requires a lot of efforts from your end as well. It requires a lot of practice as well. So having a one moment, guys. So having a very realistic expectations, I'm expecting around 8 to 9 for the average, which is currently 1 to 2 after these 3 sessions. Okay. Once that baseline is clear, now we can start with dynamic programming. To answer your question, what topics are pending now? DP, then backtracking, then trees, then graphs. These 4 topics are pending. Okay. There is one extra class we can take for articulation points and all of those things, but more or less, these 4 topics are pending in a DSA syllabus. I still get stuck for optimized version of array questions. You can talk about a specific question if we have in your doubt session, and if it is not solved in the doubt session, then I can pick it up. Okay. When you say you get stuck, where exactly you get stuck? You get stuck in maybe applying sliding window or some other approach, or it's very subjective where you get stuck, right? I have a generic question. I felt often interviewers are very interested in the output. He does not care about progress. Do you also feel the same? Output is more important than progress. Um, I'm not clear with the question. What do you mean by output and progress? Or DSA question? So you're saying that run the code and see the output. Is that what you mean? Okay. Um, Again, depends on company to company. I can tell you for the companies that I work for, I take interviews for. Any of the fund companies, you will not be running the code. Meta, Google, Amazon, any of these companies, you will not be running the code at all. You'll be given either a Google Doc or you'll be given a coder pad sort of setup where you will write the code, but you will not be running it, just to be clear. So practice on creating code on pen and paper. And nowadays they have rolled out features for offline interviews, like in-person interviews. So in-person interviews most likely will not be coding on laptop. If it is in person, then you will be coding on whiteboard. So practice with as much whiteboard as you can if you're targeting these companies. But again, organization to organization, one moment, guys. Organization to organization, it may change, right? They might ask you to run the code and so on and so forth. But anyways, it doesn't matter whether you run the code or not run the code. The idea is to write a production ready code. So anyways, if it's a production ready code, it still should run, right? Cool. Are we going to solve some recursion problems? We can take the questions if we have any. Like that's why I'm trying to finish the course early because we have been quite late in our because of multiple reasons we have been quite late in our DSS syllabus. We can take more sessions for the end of the problem statements. Okay. All right. One moment, guys. No, binary search tree is not completed. That will be the next topic once we complete backtracking. Like to start the code or first explain the use case and explore approach, then start. System design easy when compared to DSA. Guys, we are going a bit in a different tangent. Let's come back to our DSA course. I'll answer your questions, but let's be realistic that we have course to cover as well. Okay. But I'll answer these two questions real quick. It's a good way that you start with a certain template. What I prefer all of my mentees to go with the template is start with this edge cases. Whenever a DSA problem statement is given, talk about edge cases, talk about clarification, give edge cases from your end. Do not wait for the interviewer to give you edge cases, right? You take the ownership of the interview, you take the lead in the interview. And once you're clear with the edge cases, once you're clear with the problem statement, then you move to approaches. So talk about, hey, this can be the brute force approach. I can make this optimized. I can make further optimized, etc., etc. Whatever the most optimized that you can do. Usually there's 2 to 3 layers of iteration that you can do in one DSA question, which is asked in interview. Write about the approach, do a dry run if it is required, do not write code anything. Once you have an agreement that, hey, this looks good to me, while you're talking about the approach, you'll talk about time and space property of all the approach. Once you have an agreement with the interviewer, then you move to the code part and then you do a dry run. So that dry run can be based upon running the code or not running the code. This is what I would recommend. Okay. That makes very clear structure for you to communicate your thoughts. That makes very clear structure for the interviewers to take notes what they're looking for. Okay, cool. What interviewer think if we should directly go to optimize solution? They will think that you have already solved the problem statement before. That's it. Okay. So at least we can mention the brute force. You don't need to write the code. Again, I'm saying do not write the code until and unless you have an agreement with the interviewer. This is the most optimized solution. If you get a go ahead, then start writing the code. One of the major things that I've seen in at least as being on the other side of the table, people jump into writing code. When you are going for software engineering, it's not just about writing code, it's about understanding the problem statement clearly. Okay. To your question, is system design easy when compared to DSA? Subjective question, what do you mean by easy there? System design has its own set of things to excel into. DSA has its own set of things to excel into. System design is a very wide topic. DSA is a very limited topic. Limited in the sense there are limited topics to cover. Questions can be again infinite, but there are limited topics to cover. System design, there are many more things, how much depth that you want to go to. Okay. So DSA is, I would say, more breadth and system design is more into depth. Okay. All right, guys. That being said, let's start with our topic, which is dynamic programming. First thing to clarify there, DP versus backtracking versus greedy. Okay. What is dynamic programming? What is backtracking versus greedy? Let's make sure we are crystal clear with these three different set of algorithms. These are not same algorithm. These are three different pillars of algorithms. Let's try to understand the core difference between them. We'll understand with the real life example also. DP means an optimization over recursion by storing the results of previous states. Why do we do that? To avoid recalculating. Calculating. Okay. All of these things will make sense once we go with the real life example, but let's try to understand one by one. What exactly is DP? DP is optimization over recursion. So technically, whatever recursion is doing, DP is also doing, but with optimization by storing the result of previous state to avoid recalculating. Now, when you say optimization, let's clarify it. Optimization in terms of time or optimization in terms of space. Even if you don't know the answer, if you read the second statement, it clarifies it. We are storing the result. So if we are storing something, definitely we are not optimizing on space. We are increasing the space, right? So if you're increasing the space, means you're reducing the time complexity. So DP is time complexity optimization over recursion by enhancing the space range. Okay. Example of DP problem includes 0-1 knapsack, um, LCS, LIS, etc. All of these are DP based questions. Number two, backtracking. Backtracking is also optimization over recursion without storing the state results. Storing the states. The purpose of backtracking is it will exhaust all possible solutions you can think of. Okay. So think of problem like rat in a maze or n queens problem, etc. etc. All of these are backtracking based problem. What else? Greedy. Greedy means greedy has nothing to do with recursion. These two algorithms, TP and backtracking, these set of algorithms, they were optimization over recursion. One with storing the state, other without storing the state. Greedy is a different set of algorithm, nothing to do with recursion. The name itself says greedy means find me the best solution now. Okay. Don't think about future. This is the part of greedy. So what greedy claims, what do I mean by don't think about future is what greedy claims that your local maxima minima is equal to global maxima minima, which always is not correct. That's why greedy problems are heuristic in nature. Heuristic means they can give you the closest answer, but they do not necessarily need to give you the always correct answers. Okay. Example include point change problem. What do you mean by maximum minima here? So I hope all of you guys remember in your grade 11th or something, you would have studied about functions, right? Let me make it 4 quadrants. So when you studied functions, you would have studied about a graph like this. Which graph is this? Anybody? Which graph is this? Sine have the same amplitude, by the way. If it was the same amplitude where the value was going to 1 to -1, then you could have called it sine. It's following the same pattern as sine, but the amplitude is changing. Technically, yeah, sinusoidal is a term here, but I drew more in terms of physics sense. This is increasing simple harmonic motion. There's a graph for it. But anyways, coming back to it, what do you mean by minimum maxima and maxima minima and global maxima minima? If I consider a particular range, this is my global, and we'll call this as G here. Okay. And if I consider this particular range, this would be my local here. I'll call it as L here. Okay. And if I talk about the maxima here, in this local, this would be my local maxima. Agree? This is my local maximum. That's the highest amplitude I have reached to. But if I look on a global level, my actual maxima, or I can say GM, is this part. Okay. So you can clearly see that local maxima does not necessarily mean to be global maxima. That's why I said the answer will not always be correct. Cool. Clear this, come back here, come back here. Now, we talked about three different classes of algorithm. Now we're going to take a real life example to further deep dive into. But quickly revising, DP is optimization of recursion by storing the result of previous state, so we don't have to recalculate again. Back example includes 01 knapsack, LCS, LIS, etc. Backtracking is also optimization over recursion, but we do not store the previous state results. We exhaust all the possible solution. Example include rat in a maze, n queens, etc. Greedy claims about find me the best solution now. It don't think about the future altogether. Okay. Example coin change problem. Now let's try to understand the approach of a DP versus greedy solution in a practical example. Okay. So I will take a problem statement called goldmine problem. That's what we'll take an example. It's a very popular problem. Eventually you'll be solving it as well. The problem is you're given a matrix where each cell contains gold coins. You need to calculate maximum gold coins in the matrix. Okay. Given a matrix, each cell contains some gold coins. You need to calculate maximum gold coins in the matrix. The constraints that are given to you is that you can only move right or you can only move down. Your source and destination are given to you. So let's take a problem statement. I'll come here. I'll start with source 1, 10, 20, 100, 1000, 25. Let me create some spacing here. 70, 80, 90. Destination. Okay. Let me ask you a question, guys, real quick. Tell me, in this matrix, assuming that each cell contains this gold coin, so this 1000 is a gold coin, this one is a gold coin, etc., etc. You need to tell me the path which will calculate me maximum gold coins if I take that path, provided I go from source to destination and I only take right and down for my current position. Problem crystal clear to all? Problem crystal clear to all? You're given a matrix. Tell me the path which will fetch you the maximum gold coins. Going from source to destination, traveling only right and down from your current position. You guys have 30 seconds. You can message to everyone. Let me know the path from source to destination, which has the maximum point. Quickly in the chat, guys, 30 seconds on the clock. Don't give me the sum of it, just give me the path of it. Cool, guys. What's the final answer? The final answer is the source to destination path, which will give you the max number of gold coins. Is you can start with 1. If you go to 10 or you go to 100, that's the path that you need to make a decision. If you go to 100, then you can take 1000, then you can take a 80, then you can take a 90. This is the maximum that will get you in terms of getting all the gold coins. All agree? Come on, guys, begin the chat. Cool. This is our answer. Now, on that answer, let's try to understand how DP will solve this problem, how Greedy will solve this problem. Let's go one by one. So let's talk about the DP way, and then we'll talk about the Greedy way. So the DP way is, it will find all the source to destination valid path and then check for maximum. Okay. It will first check all the source to destination valid path and then it will check for maximum. So let's take an example. What can be all the path? So 1 to 10 to 1000 to 25 to 90. This is the valid path. One to 10 to 1000 it is. 1 to 10 to 1000 to 80 to 90. This is also a valid path. What else? 1 to 100 to 1000, 100,000, 25 and 90. It's all valid path. And then 100,000, 80, 80 and 90. That is also a valid path. This is going to be your answer. And let's take, if we talk about 1 to 10 to 20, then I go to 100, then 1000, then 25, then 70, then 80, then 90. Is this a valid path? No, it is not an invalid path. Okay. And so on and so on and so forth. This is how DP will give me the answer. So it will list first all the valid paths or all the valid combination, and then it will select whether we need the maximum, minimum, whatever we need. And then it will give you the maximum, minimum. Okay. How will Greedy solve this problem? Let's talk about it. Greedy, remember the purpose of Greedy? Greedy says, find me the best solution now. Don't think about future. What does that mean? When you're currently standing at 1, you're currently standing at 1, you can only move to right or down. So you have only two options. Either you can take a 10 or you can take a 100. All agree? Come on, let's put in the chat. When you're at 1, you can only take a 10 or 100. So you got two options, 10 or 100. According to Greedy, always go to 100 because max of 10 and 100 is 100. Okay. According to Greedy, always go to 100 because max of 10 and 100 is 100. So at every step, you need to choose the best solution there. You don't think about future. Remember, Greedy will not always give you correct answers. So there's nothing wrong in the approach that Greedy is following. The only thing which is wrong is the word always. Is it always give you the always correct answer? The answer is no. Let's take an example. If I talk about test case number 1, current test case. If I take the current test case, what is my expected path? We just solved this question. My expected path is 1, 100, 1000, 80, 90. How will greedy work here? If we talk about greedy output, greedy will say I'm currently at 1. I have a choice to make between 100 and 90, 110. So I choose 100. Then once you're at 100, what choice do you have? At 100, you have a choice between 70 and 1000. What will greedy choose? Greedy will choose 1000. No issues. Go to next. After, if you make it 1000, you have a choice of moving either 25 or 80. 25 or 80. What will greedy choose? Greedy will choose 80. Makes sense. Now, finally, you are at 80, you have only one chance, which is going to 90. So your greedy also gives you the correct output, which is 100, 1000, 80, 90. This is the correct answer. All agree? Quick in the chat, guys. Okay. But since greedy is always choosing the best solution then and there, it does not mean it will always give you the holistic correct answer. What do I mean by that? If I modify this test case, now let's say test case number 2, and now this value become 2000. First of all, what is the maximum path now? Quickly in the chat. What is the maximum path now? Quickly in the chat. Correct. The maximum path now is 1, 10, 2000, 25, 90. Okay. Now, what will greedy do in this case? If you come back to greedy, what greedy will do is it will start at 1, two options, 10 and 100. Greedy will go to 100. Now, the moment you have stepped to 100, can you ever go back to 2000? The moment you have stepped into 100, can you ever go back to 2000? You cannot, right? So then and there itself, it got your incorrect answer. Okay. That's why I said greedy will not always give you the correct answer. All right, guys, that was a practical example to understand how DP works, how greedy works. Basically, DP takes all the valid answer and then it gives you maximum, minimum, whatever answer you need. Greedy gives you then and there right answer. right answer in that moment. Okay. All right, guys. Now we can start with our dynamic programming. As I always say, before starting any topic, let me clear this. DD will work only for sorted inputs. Not always sorted inputs. DD will work for specific cases. Okay. Now, for DP, as I start with any data structure, any algorithm, we talked about three things that you need to know to become master in any DS or algorithm. What are those three things? Number one, what is the use case slash problem the data structure algorithm is solving? Number two, what are its real life applications? Number three, how it is coded or implemented. Okay. If you want to become master in NDS algo, just know about these three things. What is the use case? What is real life application? How it is coding or implemented? Let's try to understand all these answers for DP. What exactly is DP? What is the use case of DP? What problem statement DP is solving? It's an optimization over recursion by storing the state results. I have highlighted two terms here, which will define all of these two terms later. First, optimization over recursion. Second, by storing the state results. Why do we do that? What's the purpose of it? What's the application of it? The application is it reduces the exponential time complexity in recursion to polynomial time complexity. Okay. So example of it may reduce from big of 2 raised to power n to big of n. We'll talk about this example, which I'm referring to 2 raised to power n to big of n. Number three, now it's a time to understand about another term which is related to DP, which we'll circle back later. That is called state variables. What do you mean by state variable means? State variables is the one which determines the order of DP. Okay. What do you mean by order of DP? You might have heard it's a 1D DP, it's a 2D DP, it's a 3D DP, etc. etc. What determines this one-dimensional DP, two-dimensional DP, three-dimensional DP? It's determined by the number of state. If my state depends upon one variable only, that is when you call it as 1D DP. If your state depends upon two variables, it's called a 2D DP. If your state depends upon three variables, it's called a 3D DP. Okay. So example of 1D DP problem includes Fibonacci sequence. By Fibonacci sequence, only n is the one which is determining the state. Okay. 2D DP example, you can take off 0, 1 knapsack. We'll go about this problem statement later, where both value and weight both determine the state. 3D DP, you will be very unlikely as 3D DP problem unless it's a extremely good competitive programming contest or extremely good company online assessment. In interview, definitely won't be a 3D DP problem, so don't even worry about it. But 3D DP means you're going to have three dimensions or three different variables defining your state. Example of this, there is a question on lead code called House of Robbers 3. That is, I guess, a premium question. You can double check. This is a 3D DP problem. Okay. But 99% of the problems that you will be ever solving will be 1D DP or 2D DP. Okay. All right. Coming back to this. We'll go back to the state variable once we move to the 2D DP. But as of now, just telling you this is what exactly 1D DP, 2D DP, 3D DP means. Let's quickly revise, then we'll start with an example. First thing first. What is DP? DP is an optimization over recursion. Dynamic programming is an optimization of recursion by storing the state results. Why do we use dynamic programming? If recursion is giving me answer, why I have to use dynamic programming? Because it's reducing the exponential time complexity from recursion to a polynomial time complexity in dynamic programming. Okay. Now we'll start with the problem statement. We'll try to see how recursion works, what exactly DP is doing different, and then we'll try to solve it. Okay. then all of these words that I've said here, optimization of recursion, storing the state results, will make clear sense. Let's start with a quick problem statement. Do you guys know what pattern is this? Quickly in the chat. What pattern is this that I've written on the screen? Correct. This is called Fibonacci sequence. Okay. What's the Fibonacci sequence? Fibonacci sequence is your nth term is given by n minus 1th plus n minus 2th term. Okay. This is your recurrence relation. Your nth term is given by the sum of the previous two numbers. That's what you call as Fibonacci. So we define Fibonacci of 0 as 0, which is a base case, a leaf node. We define Fibonacci of 1 to be 1, again as a base case, again as a leaf node. If I give input n equal to 5, what is my expected output? N equal to 5, fifth Fibonacci number. Quick in the chat, guys. Correct. Fifth Fibonacci number is 3, as you can see in the sequence. Now, here is something which is problematic with line number 711. There is something which is problematic. What exactly is problematic? Let's try to understand. If I put n equal to 5 and I try to put in this relation, my expectation is I want to know the fifth Fibonacci number, I should get the output 3. Agree? My expectation is if I want to know the fifth Fibonacci number, this recurrence relation should tell me the output is 3. But there is a bigger problem here. If you put n equal to 5 in line number 711, it will ask you, if you need the fifth Fibonacci number, you need to know the fourth Fibonacci number, then you need to know the third Fibonacci number. All agree? It will not give me the answer as 3. It will say, if you want to know the fifth Fibonacci, first tell me the fourth Fibonacci and third Fibonacci, then make a sum of them. Do I know the fourth Fibonacci? No. Do I know the third Fibonacci? No. So I'll go back into the same conditions. So I'll put Fibonacci of 4. So it will tell me find the third Fibonacci, find the second Fibonacci. I don't know the third and second Fibonacci, so I'll follow the same. Find the second Fibonacci plus find the first Fibonacci till it eventually goes to the base condition of 0 and 1. So if you try to understand on a deeper level what exactly is happening, this is a recursion. And how is that recursion taking place? It's taking place from here. You want to calculate for 5, first go to 4 and go to 3. If you want to go to 4, you need to go to 3 and you need to go to 2. 3, you need to go to 2, you need to go to 1. You need to go to 2, you need to go to 1. For 2, you need to go to 1, you need to go to 0. 1 and 0. This is exactly what is happening. Now, interesting part here is, or the difficult part here is, the way this recursion is working is, if you want to know the answer of 5, go back to 4, go back to 3, go back to 2, and here also from 2, there is going to be one more level. Again, 1 and 0. Okay. So again, go back to 1 and again go back to 0. This is your root conditions. You always need to rely upon these root conditions to get answer. All agree with this? Do you see a scope of optimization here? What is the scope of optimization? Let's talk about first. Let's say if I'm calculating Fibonacci of 3. Okay, forget about 5. Let me clear this one. If I'm calculating Fibonacci of 3, if I have to calculate Fibonacci of 3, again I need to go to 1, I need to go to 2. From 2, I need to go to 1, I need to go to 0. Correct? And then I will get some answer. Let's say whatever that answer is, X. Agree? I need to go from the root condition till travel that parent node to get my answer. Now, if I have to calculate Fibonacci of 5, I am going to need the Fibonacci of 3. But am I storing the result of Fibonacci of 3 anywhere? Is it storing the result of Fibonacci of 3 anywhere? No, it is not storing. So if it is not storing, what is the problem? The problem is, again, I need to go to 43210. Here also 43210. Since I am not storing the result at any particular node or at any particular level, hence I have to always start the iteration from root till the leaf node. Everybody crystal clear with this? This is the main blocker. This is why the complexity is 2 raised to the power n. We'll talk about why it is 2 raised to the power n. But this is the reason complexity is 2 raised to the power n. Because you are doing multiple iterations again, which does not need to. DP realizes this problem and DP solves this problem. What DP says it, hey, why are you doing those repetitive calculations again? Once you calculate Fibonacci of 3, why not store there? Then once you calculate Fibonacci of 4, why not store there? And then you can just calculate Fibonacci of 5. So this is what DP does. DP says, hey, once you calculate Fibonacci of 3, let's call it as X. And let's call Fibonacci of 2 as Y. Once you have this in place, your 4 will become X plus Y. And your 5 will become 2 into X plus Y. Agree? Once you calculated 3 and 2 already, to calculate 4, you just need to take a sum of 3 and 2. To calculate 5, you just need to take a sum of 4 and 3. And that will save you a lot many optimizations. That you have to do only once. You have to iterate only once. Whenever you get the answer, you return the answer and you do it. That's exactly what DP is doing. Okay. But to make it more clear and more realistic, I will use a real life example so it is clear to you, and then we'll come back to it. We have around 10 minutes, so I'll quickly finish this real life example. Okay. More or less, this is what you need to understand. And if you understand this part, that's exactly what DP and recursion is doing. The real life example I'm going to use now, one moment, guys. The real life example I'm going to use now, it's also explain the same thing. The real life example is, imagine this is a ground floor of a building. Okay. And this is the floor where floor number 4 or floor number 5 you live. The real life example is, there are two brothers who live on this floor number 4 or floor number 5. First brother is recursion. Second brother is DP. First brother is the elder brother, so by default he is hardworking. Second is DP, he's a younger brother, so by default he is lazy, right? But he's smart also. Okay. The task is, understand the task in this. This is a, let's say, society building. This is the highest floor where both of these brothers live, and this is the ground floor. The task is, they need to collect secret Santa from all the neighbors in the society. All the neighbors in all the floors in the society building. This is their task. Okay. Let's see how will recursion perform the task, how will DP perform the task. Let me clarify the real life example here. Imagine this. This is a society building. All of these are rooms or floors that you want to call it, or units on the floors in terms of your society building. This is the ground floor. This is the top floor where two brothers live, recursion and DP. Let's see how recursion will do the same task. The task is, you need to go to each and every unit. You need to collect their secret Santa gift and eventually come back to your place. Okay. How would recursion solve it? How would DP solve it? Let's talk about it. Recursion being a hard worker, what recursion is going to do is, it will start from ground floor always. It will start from ground floor always. What do you mean by that? So in order to go to the first floor, it will start from 0 to 1. In order to go to the second floor, it will go 0, 1, and 2. In order to go to the third floor, it will go to 0, 1, 2, 3. In order to go to the fourth floor, it will go 0, 1, 2, 3, 4. This is what recursion does. Anytime it needs to collect anything, it will always start from the ground floor, 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, 4, and so on and so forth. Okay. What about DP? DP is a smart worker. So DP simply is going to use a lift. So if it has to go to first floor, it will go 0 to 1. If it has to go to second floor, it's already at the first floor. It doesn't need to go back to second 0 floor. It will take 1 to 2. Third floor, 2 to 3. Fourth floor, 3 to 4. That's exactly what DP is doing here. Okay. Understand this. What I've explained by this real life example. The only thing that I've explained is to solve the same problem statement, how the recursion would work is, since my recursion is not storing anything, if I have to calculate for 4, I still need to go to 3, then 2, then 1, and then 0. These are my root conditions. Again, if I need to calculate for 5 also, since I did not store any value here, I need to start with 4, 3, 2, 1, 0. This is how recursion works. Everybody crystal clear with this? Come on guys, quick in the chat. Everybody crystal clear with this? Cool. This is how recursion works. The DP, how it works is, it saw that problem statement that recursion is recursion is traveling the same particular node multiple times because it is not storing the result. If we calculate that answer and we store the result there, we don't need to revisit it again to the ground floor. Okay. So that's what the purpose of elevator here. Okay. How is that elevator thing happening is, let's say you calculated Fibonacci of 2. Let's call that value as y. And you calculate Fibonacci of 3. Let's call that value as x. Once you have calculated Fibonacci of 2 and Fibonacci of 3, now you don't need to go back to 0 and 1 or ground floor all the time. If you want to calculate Fibonacci of 4, you already have the answer of 3, you already have the answer of 2. If Fibonacci of 4 will be just x plus y. All agree? Come on guys, click in the chat. All agree? Cool. Similarly, if you want to calculate Fibonacci of 5, you already have Fibonacci of 4, you have Fibonacci of 3, just add 4 plus 3, that will be your answer. Okay. This is exactly what DP does. Okay. Now I'll take a step back. I'll quickly revisit whatever we explained in terms of DP. Then we'll come back to the implementation part. What part is done? How part is done? Coding part will come back to it. Okay. So first thing first, what exactly is DP? DP is an optimization over recursion by storing the state results. We already talked about what are we optimizing by storing the state result. Recursion, we need to revisit the multiple states multiple times because we are not storing the result. If we store the results, we don't need to. That's exactly what DP does. Why do we do that? Because since recursion is doing it multiple times, that's the example I have taken via ground floor example, the complexity is exponential here. We try to reduce that exponential time complexity to a polynomial time complexity. In the case of the example I've taken for Fibonacci, it is reduced from big of 2 raised to the power n to big of n. And you know 2 raised to the power n to big of n is a very big optimization. Then we talked about state variables. This is related to specific to DP. We can skip that part in the revision. But what state variable means, determines the order of the DP, how many variables are contributing to the state. We took an example to understand this in detail, how recursion works, how DP works, what exactly is the optimization here. The way this sequence works, Fibonacci sequence, this is a recurrence relation. So Fibonacci of n is n minus 1 plus n minus 2. My expectation, if I put n equal to 5, I should get the answer 3. But that is not how this code will work in recursion. For 5, it will ask you to go back to 4, 3, 2, 1, 0. Again, for 4, it will ask you to go back to 3, 2, 1, 0. It will always ask you to start from your ground floor, basically your leaf node, back to that root node. That's the example which I was explaining here. In the case of DP, what it will do is at any moment it comes, if it has calculated it, it will store the result there. You go to any node, you store the result there. So next time when you have to go to that node, you don't have to start from the leaf node. You can pick up the result from there and you can continue. For example, you visit the first floor, you calculate all the secret centers. Then you go to the second floor, collect all the secret centers. You don't need to go back to the first floor again. Okay. This is what DP will do. And that's the optimization of DP over recursion. Everybody crystal clear with this? Could guys quick in the chat? Yes, DP reduce the time complexity, increase the space complexity. Correct. Okay. All right, guys. If that part is clear, let's quickly revise what you've done as part of today's session. I wanted to write code, but we wouldn't have time for that. Or maybe we can quickly write down code and see the complexity also. Okay. Recursive solution and DP solution. You can quickly spend a few minutes to do that. So if I write the same solution, Fibonacci using recursion, integer n, first I'll define the base condition. If n becomes 0, return 0. If n becomes 1, return 1. Otherwise, return Fibonacci of recursive n minus 1 plus Fibonacci of recursive n minus 2. Okay. If we have to write the DP solution, how will the DP solution look like? Let's call it as integer Fibonacci of DP. This is integer n. First integer result is going to be new integer n plus n. Why n plus 1? Because I'll be storing for nth Fibonacci number. Nth Fibonacci number also. So base case again, result 0 becomes 0, result 1 become 1. So for I equal to 2, I less than equal to n, I plus plus. The result of I is going to be result of I minus 1 plus result of I minus 2. Then you return your result of n minus 1. Why n minus 1? Because n minus 1 is corresponding to my nth Fibonacci number. Let's talk about time and space complexity quick. For this piece of code, what is the time and space complexity? My time complexity is big of n. My space complexity is big of n. Agree? This is just one iteration, big of n, space complexity is big of n. All agree with this? Cool? Cool. Let's talk about time complexity of and space complexity of this code. Complexity of recursion, in case anybody doesn't know, is determined by big of branches raised to the power depth. How many iterations you are doing? Branches raised to the power depth. So we only talked about the tree diagram for this one. It has 2 branches, depth is up to n. So 2 raised to the power n. And my space complexity is big of 1 if I talk about in memory space. Line 811, result of n. No, it's purposefully n plus 1. If you want to keep 1 base indexing or 0 base indexing, yeah, you can decide whether you want to keep 1 base indexing or 0 base indexing. Okay, so you can keep it in here. Now, here in this case, in recursion, my space complexity is big of 1 if I talk about in memory. But being recursion, it will take auxiliary memory which is a recursion stack. A recursion stack is something which is saved in the heap memory. So when you call Fibonacci of 5, let's take, this will make a call to Fibonacci of 4, make a call to Fibonacci of 3, which will make a call to Fibonacci of 2, which will make a call to Fibonacci of 1. Okay. This will be done in a stack fashion. All right. All right, guys. This is the optimization I was talking about. From 2 raised to the power n to big of n, this is the optimization which DP has done. This part which I was referring to. This is Fibonacci of recursion, and this is Fibonacci of DP. Everybody crystal clear with this? Quick in the chat. Everybody crystal clear with this? Cool. Let's quickly revise what you've done as part of today's session, and then we'll wrap up the session. So we have completed a hashing set and map question. So I'll just mark this one as done. This one as done. These are the question already in your assignment. Now, we started with dynamic programming. This is currently a work in progress. We'll continue with dynamic programming, 2 more sessions that we'll take, and then we'll move on to trees and graphs. Okay. Now, I'll answer your question a bit later. Let me revise quickly. We start with question number 3, which is rate code 389. Find the difference. There are many ways to solve this question. We talked about all the 10 different solutions, starting with brute force, sorting and two pointers, keeping two map, then one map, keeping two frequency array, one frequency array, XOR in two pass, XOR in one pass, sum of ASCII character, and optimize sum of ASCII characters. Okay, all of these solutions we talked about. Time comes t, big of s plus big of t, space big of 1, most optimized one. Then question number 4, lead code 819, which is most common word, very good problem statement. The only reason it's a lengthy problem statement because there are multiple validations that you need to take care of. Okay, so we went to step by step. First, we convert paragraph into array of strings using rejection split. Once we got that, I'm going to convert all stringer and string words to lowercase. So I have to match with the band array, which is given lowercase. Now my question becomes, I need to compare between two string arrays, find the word which has the highest frequency. Highest frequency will be taken care by map. And in terms of comparing between two strings, I can convert the band into a set. So my lookup time will become big of 1. Okay. Then we move to the code part. We verified everything in code. Time comes to big of n, space big of n, passed all solutions, most optimized solution. Then finally, we start with our new topic, which is dynamic programming. So first I made an initial analysis where you guys currently stand or how confident you feel in DP problems versus recursion problems. I set a realistic expectation for average of 8 to 9. Once we finish, we're going to do at least 10 to 12 questions on DP. Once we finish our DP, then we are going to have a reassessment of 8 to 9, and then we'll talk about how much realistically we achieve that. First, we clarify the difference between three different classes of algorithm, DP versus backtracking versus greedy. DP is optimization over recursion by storing the results of previous states. Backtracking is optimization recursion without storing the states, and greedy is not related to recursion at all. It is find the best solution now, don't think about future. Okay. We try to understand DP versus greedy using a practical example of goldmine problem. How DP solves is, it's going to find all the source destination valid path, then check for the maximum. The greedy what is going to do is not going to check about all the source destination valid path. It's just going to take at this moment what is the best answer right now. Don't think about future. Then we move to detail of DP. We talked about coding part also done by the way. So we talked about purpose of what exactly is DP. It's an optimized recursion by storing the state results. Why do we do that? Because it reduces the exponential time complexity in recursion to polynomial time complexity in DP. We talked about state variables. We took an example to understand Fibonacci sequence. We look at the recurrence relation, tree diagram, a real life example to understand how recursion works and DP works, and finally writing down the code for both recursion and DP. Complexity from big of 2 raised to the power n to big of n. Everybody crystal clear? Give me clear in the chat. Whatever we discuss as part of today's session, everybody crystal clear? Give me clear in the chat. Okay. There's one question that I saw in the chat. One thing I want to ask, some question takes time in log, kind of in this case of log time complexity. Read about logs or do I not struggle to visualize it? Some question we solve takes time in log, kind of wrote things in case of log time complexity. What and where to read about log so I can visualize it. If you want to just visualize the log function, I mean, if you're asking in terms of log function, I would say binary search is a good place to understand that. Because in programming, log is everything base 2. We don't call about base 10 or anything else. It can be base 3 depending upon ternary search, but mostly these are base 2. So in binary search is a good start to visualize the logarithmic complexity. Okay. Does DP remove the older saved data and just remember the recent step data? No. We are storing at every place. So if you look at this array, this part, it is storing for each and every value here. Entire array is filled with that. Every state is stored. Okay. All right, guys. Everything is clear. Let's wrap up the session here for today. Let's catch up in the next session and we'll resume with our DP. Thanks for joining in. Have a good way and we'll connect in the next class.